All right. Hi guys. Last session, by the way. Yesterday, hello. So last weekend we were kind of exploring, okay, what are we doing next? And we realized, oops, that's the last week of the semester, at least for you guys here. It's a bit of a pity because there's way more to talk about, as you guys know. So our only solution is to come up with an additional course, a Cloud 2 or something like that, that allows us to cover a bit more range. But for now we can't. So we kind of need to wrap up. This morning, that at least was the ridiculous deadline that was set up by course management, if you like. So the review of the assignments will happen tomorrow. So we'll expect that all assignments are running somewhere, right? So, well, you choose a platform of choice, right? Something you know or wanted to try out and it actually works, plus source code, and then we'll mark it in the groups, in your respective groups. So we expect you to be here and have a running application. Then you run us through some the base idea, and then we give you marks at the end. Well, not necessarily like in real time, but Expost will provide you with marks. So the idea is, in contrast to the previous assignments, we're not requiring you to submit them explicitly, like in a submission system, but we'll just use the commit as of 7 o'clock this morning and trust you that you set up those systems or get them up and running. And then run us through aspects of how did you develop it, but also deployment questions, because we didn't really ask deployment question in any of the previous exercises, but that's more relevant to the current one. So, cool, but apart from this, let me just switch off my notifications here. Apart from this, so yep, the microphone still records. We need to go through a review, right? So some of you came to me and asked, okay, what are we actually doing in the exam? Since we spend most of our time doing something in the terminal or in IDEs or other forms of coding environments. And that's why we're talking about it today. So yeah, so I think when is the exam?
In 9 days.
In 9 days?
Yeah.
It's tight, right? Okay. So reason enough to talk about it today. So the exam will obviously focus mostly on theory, some, theory in the widest sense, aspects we talked about, which are not really core theoretical in this course, I guess, because in the end, many of the questions will relate to your coding experience, or experience you made with Go. Nothing you actually need to explicitly learn for, unless you didn't code your own code. So that shouldn't be much of a problem there. So, but looking at the bigger picture, the theory that we talked about, it's probably worthwhile to run through a few ideas. Generally, there's three, when we talk about cloud technologies in particular, there's three types of questions we probably need to ask ourselves. And they are, what are those questions perhaps, if anyone wants to take a wild guess? It is a wild guess.
What type of service is it?
So again?
What type of service is it?
Yeah, what type of services do we deal with? Yeah, very good. What's another one? Yep, let me see.
How much control do we need?
Cool, yep.
IaaS, PaaS, etc.
Yeah, this question is better than what I had in mind. Okay, yep, okay. Another one? No one? Yep. Anyone? Yes? Marius?
I didn't hear the question.
So what are the typical questions we will need to ask ourselves when we think about cloud services? Only one, not all of them. So we had what already? Yep.
The security aspect?
Security aspects, yep, those are the kind of the framing it around what are the challenges, right? So the boundary cases of when should we or not use cloud computing, right? Yep.
Amazon versus cloud versus.
Yes. So we need to know about those things, but be relieved, we will not ask specifics about all those three in the exam, right? So that's just to clarify that in advance. But yes, you would want to know all those ones. Yep. So, but there's another. So if you are now switch perspective a bit, apply some empathy and think about being a business owner, right? So you're running your own startup, for example. What other question do you need to ask yourself? We had the what question already. What are we running? Yeah, that was a good one. Just repeat this. I have ears everywhere. Yes, how? Yeah, okay. So how do we actually realize what we want to realize? But there's a question that comes before that.
Why?
Yes, why? Why are we doing cloud technologies, right? So why don't you just spin up your server, put your application, your what on it, and have some ways of how to realize it? But why are we actually using cloud services, right? That's one of the fundamental questions we need to ask ourselves. And that's an understanding that you should get from this course as well. So it's not just about hacking away and knowing yet another programming language, which is cool and probably gives you a job, but you also need to know why you're actually doing this, right? Because the language itself is not related to cloud technologies. It's used in cloud technologies, it's the how, but it's not so much telling us why we're using it. So those are the questions we're trying to answer to some extent in this course, and that's why you probably need to answer those in the exam as well. So, as simple as that. So cloud computing, what is it? Why are we doing this? So those were some of the fundamental questions we asked ourselves, I guess, or at least now we start asking ourselves those questions. What were core characteristics of cloud computing? Just, we talked about them like 10 weeks ago, roughly.
Abstractions and distribution.
So yeah, distribution is definitely in there. So so the abstraction is a really good one. That's cool. It's a good exam question, or answer rather. Yeah, what else? Distributedness. Now look, yep.
Virtualization.
Yeah, virtualization is the kind of the how issue, right? So it's like, how do we do cloud computing, right? So, but it fits into the what is it? Yep. Anyone else?
Scalability.
Scalability, right? So it's one of the topics we talked about as well. Yeah. So yeah, those are the main things. So we had distributed computing, scalability, we had abstraction, so which is virtualization in a similar fashion. Cool. And the question is why we're doing it. And what some of the key aspects that we talked about is the fact that data and services are remotely hosted, so you don't need to deal with this yourself anymore, right? So you host it on somebody else's machine, basically, with all the implications that go along with this, like you guys mentioned, security and the like. One of the central benefits there, instead of just hosting it yourself or hosting it elsewhere, is that it's ubiquitous, right? So you wouldn't actually need to be worried about your customer base because you can suddenly move your services towards the customer. In I think week 10 or thereabout, we looked a bit, I think we were briefly spun up servers in 2 different regions, had considerably different latency metrics, right? So depending on where you actually spin up, which region you actually spin up your service. That's something that previously has been really reasonably hard. If you had a virtual host provider, usually they had 1 data center, but not 34 or the like, as provided by all those 3 big ones. So which is now at a click of your hand available. And the third thing is about that computing power is reasonably commodified. So you don't have those massive spending in advance. If you're starting your startup, you will not have the money to just set up your little server farm to do your number crunching for you, especially if you have a service that demands a lot of computational power, needs to be scalable, or has seasonal dependence, such as increasing sales during one season or doing simulations or the like. But with this approach, cloud computing, you commodify the idea of processing. Not only processing, what are the other aspects that have been virtualized in cloud technologies? Open question.
Storage.
Storage, yep, what else? So we had processing, storage, what else? Networking, right? So it's the big 3 ones, so storage, processing, networking. And we actually didn't go too deep into the networking bit, I guess, right? So it was a bit of clicking around in OpenStack to set it up, but you still should have still gotten the appreciation that you need to do it, right? So it's not something that's done for you in IaaS services if you're actually dealing with infrastructure. So, but again, all of those are at your avail right now, but basically controllable from a browser, if you like. So generally the idea is everything that has AS at the end, so yeah, be it infrastructure, platform, or software as a service, it means somebody else is doing it for you, right? So you don't deal with this, and we don't know what's coming up next. Does anyone else know another as a service model? SaaS, PaaS, IaaS. What else? Anyone else? Marsh?
I was not paying attention, so.
Oh, you didn't pay attention. Okay, okay. Did anyone else not pay attention? Just to seems to be my average student here. So okay, good to know. So well, I don't think we have any other distinct acronym right now there, but there's increasingly move to having lower level virtualization that goes beyond the infrastructure itself. You know, so you basically virtualize either entire data center, or you componentize your services or your applications into smaller chunks that are as simple as functions. So you basically represent your entire code on a function basis and are charged for invocation per function, for example. In this case, it's no longer a processor cycle that you charge for, but in fact, literally invocations. Similar on network, you're charged per bytes of transmission, whatever the unit is, and so on. So there will be new models sprouting up eventually, whatever they will be called, but it's something to bear in mind.
And
Yeah.
on the
Yep.
lowest level that they have is networking as a software. So you can model access to your network layer as a software service as well.
Right.
So there was a talk on Web Summit about optimizing, for example, your DNS. So normally you deal with DNS by, ad hoc registering your domain and then letting the DNS manage it itself. But then if you are attacked or if somebody tries to poison your DNSs, then the application basically goes down. So they were offering like you can manage the DNS layer from your application layer yourself. So you kind of influencing the underlying network and the networking infrastructure from the logic of your application.
Cool. So that may be one of the next things to look out for. But again, we're working on this rather high level. It was more focusing on application development right now. But it will affect you because you will need to think about how to scale your future application, right? So one of the key messages I think you should have taken away is that thinking about how your entire application is, or what services your entire application is made up of, and which ones can be scalable and which ones don't necessarily need to be scalable or can't be scalable in the first place. Cool. So those are the three service models we talked about. I think it should be roughly clear. SaaS, basically everything is managed by your provider and you just hook in and use those services or the software in the extreme sense. Examples for that are software as a service. What's an example?
Office 365.
Yeah, it's a classical example, right? So something you use as well, right? So you have an Office account, Office 360. No?
Not using it.
All right, you have, but you're not using it. Okay, fair enough. Yes. Okay. So the collective
Which
view.
one is even more abundant, like software as a service? Yeah.
Sorry?
Which service is even more abundant than Outlook or Office 365 as a software as a service example?
Share LaTeX?
More abundant. Okay. Interesting. Interesting. Who uses Share LaTeX on a regular basis here? Okay. Yeah, that's roughly 5, 6. Yeah, perhaps 10. Yeah. Let it be 20% at best. Okay. Okay. Abundant. Yeah. I don't know. Anything else? Yep.
Google Docs.
Right. The whole Google ecosystem, basically.
Yeah,
right. So.
World of Warcraft?
World of Warcraft. Okay, again, next question. Who's using World of Warcraft in this classroom or has been
It's
using?
only a few million.
But isn't it quite historical already? I don't know, is it still? Okay, I probably need to be very quiet now. But so I'm not sure how active that still was. I remember that was in the mid-2000s. Anyway.
It's quite funny because a lot of people associate Google with Gmail. They think Gmail is like a highlight of what Google is doing, but Gmail was actually like a side project done by some employee in this 20% of time that they're supposed to do stuff for themselves. So Gmail became kind of a very successful software as a service application, being a hobby project of one of the employees. Yeah.
Sweet.
The invitation thing in the beginning of Gmail.
Mm-hmm.
was like everyone was trying to get it, but you needed to know someone.
Yeah.
So it was kind of exclusive. Same way Facebook was only for certain universities and everything.
That's right. Initially, yes.
Yeah.
Yeah. True. It was quite competitive there. Yes. But still, those approaches still persist, right? Those by invitation participation by invitation only, right? So, what was the recent example? I forgot. People are desperate to get an account there as well. I don't know. I don't know. Yeah, but you're right.
One example I know is Elo. Do you remember Elo?
Yeah.
That was invitation only as well, and it had the kind of a very peak surge, and like in about a week, and then it completely died off.
Yeah.
So those invitation only services are not guaranteed to succeed, but they do spike an interest definitely because they create scarcity, and that's the whole philosophy behind Apple as well, and behind game releases too. Right, you create a hype, and then people to get it, they have to either queue or wait or something, and that generates more demand. So
Yeah.
Bitcoin works that way because it's a limited resource. So the more people want it, the higher the price goes.
Cool. Yep. So, right. Okay. Back to
Back to cloud.
cloud. Whatever. Let's make that an exam question and move on. No. So the other things. So SaaS. The other things we talked about was PaaS, right? So I think no elaboration necessary. What are the problems with PaaS or limitations? Anyone? Are there problems, limitations?
You rely on their implementation of the
Yeah. So you pretty much buy into their infrastructure in the widest sense, right? So or their API, if you like. So yeah, you need to change your everyone who worked with the Google cloud environment probably experienced that in most extreme case. You need to rewrite your application to suit their model, not yours. So meaning once you have have considerable sunk costs, meaning considerable time and code investment into a particular solution, then it's probably very unrealistic to move away from them.
What's the technical term for this? Lock in.
Vendor lock-in, yeah.
Yeah. You become a slave.
Pretty much, right. A slave to their pricing model, yeah.
Big.
Right.
Yes.
Yep. So, but to a varying extent, so you can obviously have the same also with IaaS, right? Why is that the case? Can we have, where can we have vendor lock-in in IaaS? Anyone? It's probably more based on your intuition because I realized we didn't really talk about this. Yep, please.
Once you started doing stuff in Amazon, you can't really just jump over to Azure, I'm guessing.
That's right. So it's kind of the same pattern. So when would that be the case, for example? I mean, as long as we're clicking around in the browser, everything is fine, right? But when is it particularly tricky to actually shift from one to the other vendor?
You're dependent on their services.
You depend on their services. That's right. Anyone else? Yeah? No? Yes?
When you're configuring environment variables.
When yeah, okay. Those specific, but they apply to PaaS as well, right? So you can have the same with a bit more control in IaaS services, though. No, what I mean is we didn't really do this, but you can basically spin up your entire infrastructure by code as well, right? So you write your own whatever in whatever language. So AWS provides a rich set of SDKs for a large number of programming languages, Go, Java, Ruby or the like, and you can basically spin up remotely services in AWS, but you need to script them against their API. So you're basically again buying into an API, which is AWS, and it provides you all the richness of infrastructure as a service model, so building your own network. But to build this, you nevertheless need to buy into the API. Yeah? So it's a lot of discussions about standardizing this particular access, because this really makes you dependent on on a particular vendor. Because realistically, if you're for example, need to spin up, automatically spin up another instance of your software system autonomously without user intervention, you need to interact with the APIs. Please.
So has Docker solved that problem on the platform level? Sort of, like you can just
Very nice.
send the containers around?
That's precisely the idea there, right? So that you actually solve it on a bit of a higher level already, right? But nevertheless, Docker only solves only part of the problem because it doesn't solve the issue of spinning up the underlying hardware, right?
Yeah.
So it just spins up the container or containers, and it may even do so across multiple nodes, but someone else needs to bring up those nodes. So you need to have something like Docker Swarm. But again, in this case, you still need to physically, well, virtually physically, spin up the individual instances and register with the Docker Swarm, and then you can do the magic of distributing software. So there's still an underlying layer that needs to be dealt with. So Docker doesn't quite solve the whole problem. Yeah. So it solves the software side of things, not the hardware side of things, the virtual hardware side.
So they're slowly working their way, like top down.
Yeah, so they incrementally built up. We kind of started that process a bit, right? So we looked at individual services and containers, and then we looked at applications more comprehensively across multiple containers, right? And then you need to think about, okay, now we look at scalability. So you probably need to consider multiple nodes. So you need to look at Docker Swarm, for example. Then you can group different services with scalability behavior and attach it to particular nodes and so on. And then you need to think about, how do I spin up more nodes and automatically register those with a Docker Swarm? So the scalability can, those can be exploited in case of peak demand and the like, right? So that's not something we dealt with. This would be really, dealing with Docker Swarm or Kubernetes as underlying frameworks, and that's beyond what we are looking at in this course. Again, Cloud 2. So we'll see how it goes. So vote for Cloud 2 in case the question comes up. Right. So, but again, so in all those scenarios, we have some notion of vendor lock-in, right? So if you are investing considerable money in actually, or time in writing against the AWS API, it's very expensive to change that. So most likely, you're again subject to their pricing policy. Yeah. So, which you're anyway, but the change in pricing policy. So you're a bit of a slave to their ecosystem there. Yeah. Cool. So to coming back to the key characteristics of IaaS, we talked about them some time ago. I hope the slides are somewhat legible. Again, this is basically just copied from earlier slides anyway. So the key is really about having the ability to provision new instances on demand, and obviously do scaling as well, whether manually or automatically. Again, we only talked about the manual case, if at all. You have fine-grained control, actually more control than you would have possibly in your own hosted solutions. You can really go down to a very fine level of managing service, including monitoring, allocating particular services to particular instances and so on. Something that would afford a lot of configuration in advance in your own data center to get to that level of control. But AWS needs to be quite good at this because they charge you for everything you do. So they obviously need to monitor everything you do as well. So, but on the flip side, it gives you the advantage of having extraordinarily precise or refined access to any sort of metrics, being log files or processor use and the like, or service use. So obviously, IaaS generally provide a wide set of services. So we saw it in the AWS case. It was far more than providing you a runtime platform for virtual machines, or a storage API, or images API, or volume management. But it was really about providing you AI components that allow you to do deep learning applications, batch processing of very simple applications. The oldest application is just about storage in AWS's case, so S3. So you can basically just store data or host your website there without any bothering about the underlying infrastructure, really. So it's a bit more borderline to a PaaS service, so platform as a service approach.
To some extent.
Monitoring to some extent.
Because
both ways.
Because the moment you start using the storage and the moment you start paying, you have to get intimately accustomed to how the storage model works. Like, do you storing it for frequent access, or do you storing it for long-term backup? And that reflects the pricing model reflects the usage patterns that you're doing. So again, there is a bit of a lock-in, because your policies and the way you're using the storage will be tied to, say, S3,
Sure.
right?
Yeah.
If you want to move it to Azure, they may be doing something slightly different. Yeah.
But S3 goes beyond it, right? Because you can host websites, for example, out of
You
web
could, exactly.
S3 without the use of EC2.
That's right, yeah.
So it's really borderline there. So, but yeah. But there's a large number of further services. So in fact, they were discussing it earlier. There's actually the boundary between PaaS and IaaS will basically just vanish entirely and will be consumed by IaaS providers, because they basically provide everything you can find on Heroku-ish as well in AWS already, right? So again, if we think about serverless computing, where you basically deconstruct all your applications just by looking at the functions and basically plugging them in into different modules and so on, and let AWS do the rest for you, then it also means that you basically have a PaaS platform, and that is the necessary next step that you find there as well. So so it will merge eventually, those two characteristics. But the core characteristics of IaaS are generally having some environment for running virtual machines, container services. So they have native support for Docker. So you can, instead of spinning up your instances, you spin up your Docker containers on their platform, and this is scalable then. But again, it has more of a PaaS flavor then, because you're basically relying on them scaling it up and down, so you don't get access to the underlying infrastructure in this case. Again, as mentioned, large files or file access generally, storage is one of the things to be managed, and networking as well, right? So you need to deal a bit with networking in OpenStack as well by setting up your default network, but there's obviously much richer opportunities or functions there, such as managing DNS service. If your own domain, host it on, or point it to AWS and manage it from there, and then point it to your respective containers and the like, right? Beyond the whole monitoring services and software configuration management. What was software configuration management? I think we briefly talked about it. And I think it's just a term to be aware of, even though it's not core of this class. Anyone? Or desired state management? It's another term that's used. Yeah?
Environment variables.
Context. So yeah, can be part of it. Yeah, but more specifically, what does software configuration management do? Louder. I think you're right as usual. So just give it a go.
I was just saying software, like configuring software.
It says, right? So yeah, but where and when and so on. That's right. So all of them. Okay, that was an interesting fragmented answer, but the essence was captured there. So basically, you have a fleet of instances, VMs or whatever else. The idea is that they're all configured in the same uniform way, right? So and you can automate this configuration using software configuration management tools. So and for example, to have a set of VMs that all run Docker, right? To get to that state, and then you could deploy your Docker containers onto those ones, for example. Anyway. So those are the core IaaS functionality, but I think we talked about all those aspects here. So so in PaaS, you generally don't need to deal with anything other than your application. So if there's some semantic or syntactic issue, you need to deal with this on your level. Other than that, you need to rely on the platform vendor to do that with all the advantages and disadvantages. Meaning, if Heroku is not attending to DDoS attack, then yeah, bad luck. So you can't do much about this really. In an IaaS infrastructure, it's more on you to deal with many of those aspects. So you need to deal with profane things such as system updates, as well as managing your own application and the network and the routing aspects of it and so on. So basically you have the full access, but obviously a bit more challenging in terms of usage. You need to be more competent in terms of managing the entire stack of IaaS services effectively, as opposed to just focusing on programming. So as Marius mentioned before, a general pattern in startups would be to use PaaS services first, right? To get the initial product out quick and running, and not worry about the runtime elements. But as soon as the product is picked up and grows in scale, then it becomes quite worthwhile to rethink about how to manage that as at a cost-efficient level. So one example one way would be to move into infrastructure as a service providers and actually rewrite your application to work on your servers, and you can then manage the scalability much more fine-grained. So general approach. Cool. So yeah, I don't think we need to talk about those things. That's just cool. The big three, who are those again? Perhaps someone else in this corner. The big three in cloud computing right now. Again, this corner. Yeah. yeah, sure.
Google and Amazon and the last one. Azure.
Yeah. Who owns that thing?
No, Microsoft.
Microsoft.
Oh, Microsoft Azure.
Yeah, that one. Yeah, cool. So we have all the big three ones. So right now they are the main players, but with considerable lead by Amazon, right? So that's quite relevant. Cool. Yeah. So I'm not sure in how far we can go into particular features there. We talked about many of those aspects. In terms of cloud characteristics, we think about the why aspects. Why we're doing is, well, you can actually get off the ground pretty quick. You don't need to think about underlying hardware and the like services. You can concentrate on stuff that's relevant to you. If you, for example, want to do a business intelligence application, you can use the AI API by AWS and or do some automatic analysis and so on. You're buying basically again into other people's frameworks, but you capitalize on the fact that you don't need to build everything from bottom up. You don't need to provide your full application, but use other people's services in across all levels. Just for particular software, meaning you want to have a email solution for your company, you use SaaS services, you want to program in a programming language you know, but you have no clue about the rest of it or don't want to manage it, you're well off with a PaaS service. And if you want to run an entire data center but simply don't have the funds to do that, at least not the fixed cost, then that's easy as well. So you can basically scale your cloud service needs to your abilities and resources. We talked about flexibility and elasticity. So the idea is that you, to some extent, can manage the elasticity, well, the scalability of a system, right? So when it scales up, scales down, and so on, you get more autonomy the further you go down the stack. And with SaaS services, you're pretty much limited to just using it and hoping it works. And in IaaS services, you manage that yourself. We got closer to that one using Docker, for example. And the pay-as-you-go model, again, is prevalent here. So you pay as much as you need, but generally you don't have any fixed cost. Would be interesting to see if we see fixed cost models arising in the future for those kind of aspects. Unlikely for now, but who knows? Cool. So from company point of view, that's more like the business perspective, if you like. Mariusz alluded to that in what was that, week 5 or something, so quite some time back. The idea is to move away from infrastructure. So companies shouldn't manage infrastructure. One is now a reasonably current example is Cisco again. Cisco was famous for its routers, right? And basically selling those, and you need to buy into the iOS, their native operating system. So not the Apple one, but the Cisco one, and which was uniform and taught in many networking classes and so on. And they moved entirely away from this. So right now they have a kind of rental model for their routers anymore, so subscription-based as opposed to selling hardware. And they're increasingly moving into software-based network or virtualized networks entirely. So you have your entire infrastructure virtual on networking level as opposed to physical. And that is the last, the hardest part, I guess, to virtualize, because we have known virtualization of computing for quite some time already, since the 1960s, and virtualization of storage is also unproblematic. In fact, file systems could accommodate this intermediary layer for a considerable time already, but networking seems to be the latest trend here. And you, if you're running your own company, even IT company, you should be independent of that, not really require any infrastructure other than a fast internet connection and some sort of, client's machine, I guess. So not really invest much into the server side. You obviously become a bit dependent there on network connectivity or internet connectivity, something to bear in mind if you live in a more remote region, such as West Coast in New Zealand, for example. So that's probably something where you would want to consider keeping your servers in-house. But that's the key idea. So moving away from dealing with infrastructure. So yeah, so I think we talk about this like n times. Some challenges obviously is connectability, meaning if the question is not only can you access your services, but are they available to you? Because suddenly your in-house IT also depends on infrastructure, not only your customer access. Who controls the data, really? I mean, you know, you do to some extent, but there's a lot of uncertainty about it, especially here in Sweden. There was a big debate about it, and in continental Europe about storing data on US-based servers. Yep.
Can you just say here in Sweden?
Here.
We are in Norway.
Yeah, I know, but okay. Well, here and well, we'll see. Possibly. If I did, I'm sorry for that.
We can review the video.
We can review the video and make a vote on it. So yeah, not quite. But in Sweden, in fact, there was a discussion about precisely this problem, right? So where we can host data and who has access to it. So they used outsiders to manage their local data centers, but the data was sensitive or specific to Swedish administration, so not a choice. In Europe, there's also a debate about being able to the restrictions of dealing with customer data extends only to the national boundaries. So data generated in Europe for customers, and that will get worse within the next year. There's this new law, GDPR, which is it's a bit of a pain for everyone. Because do you want to elaborate?
Well, so there is a new provision by European Union which enhances the handling of personal data, and all companies who have customers in Europe have to comply. So the first thing Twitter and Facebook did, they changed their terms of policies and so on, and you've been presented with the new terms of service saying if you're a European, you basically waive all your rights because they want to keep doing what they're doing. Under the new European provisions, they can't keep doing what they're doing. They have to pay more attention to your privacy. They have to require permissions for letting third parties get your data, and for processing, they have to have an intent of why they're processing your data. So a lot of algorithms and a lot of neural network training is done with no goal. It's just to find out what can be used, what we can discover, and then use it to monetize on the data that they have. So companies which are in Europe, I don't think they can easily ask you to waive your rights. They may require to change the way they operate to comply with the new regulations, and there will be some grace period where all companies will kind of have to comply. And the interesting thing is that if we take all the regulations literally, for example, the tax office in Norway will be unable to operate because they also violate a lot of those provisions. So what's the option? I mean, the easy option is they will have a tick box saying, okay, I actually waive my rights and you do whatever you need with my data, which is probably what they will do. Or they will investigate of how they can comply and make certain implementations in such a way that they would comply, but it's difficult. And difficulty stems from the fact that most of those regulations are done by lawyers and they don't fully understand the technological implications. Same as with the cookies, right? The lawyers insisted that the users are presented with the tracking information and so on, and that's why in Europe you always have those cookie pop-ups saying you that, you know, websites store cookies. That didn't change anything, right? It didn't really change the businesses, how they store information, how they do tracking for advertising. So companies comply, but the actual change that, you know, didn't happen. So with this privacy considerations, we don't know yet. We are kind of working with the Norwegian tax office to see if the Norwegian tax office could comply using the latest developments in you know, privacy tech and public-private key infrastructure and so on. But it is a very hard technologically to achieve that. But it is kind of a move towards the right direction. It is to restrict the ability for commercial companies to kind of you know, utilize all the data that we basically giving them for free with no influence on how it is being captured and how it is being handled. So yeah, it is kind of an interesting space to see.
Right.
Yeah.
I think it's also discussion in the scientific sphere and how far you can still apply deceit. if you're asking questions, because you need to declare the purpose of any data you collect. So sometimes you have those approaches to actually shift your focus from the question they actually want to explore in order to have a more objective or more honest response to your question. So, but this is considered then misleading because you don't declare the actual purpose anymore why you're collecting particular data. So there's a bit of worry about this as well. So, but this is most related to the idea of compliance here, right? So, and how far do cloud services comply? And it may be as simple just, right now it's oftentimes as simple as to where do you store the data, right? So can you control this? And you can increasingly. So usually at a higher cost, if you use a data center that's closer to you or has higher compliance standards, it's usually more expensive than the cheaper US ones that you could use. So something to be aware about as well when you make your choice there. And of course, what features are available is quite important. How active your cloud provider is. Are they actually expanding their services or having a stable ecosystem? So would you need to use multiple services eventually to actually exploit a richer feature set and so on? How you do this? How would you do this? And there's hardly any standards in terms of APIs, for example. A lot of de facto APIs. Again, AWS leading the pack there. But even OpenStack, for example, uses some of the EC2 APIs for its own container or virtual machine management. So quite a bit of challenges there.
There is a little bit of effort coming from the ISO standardization to standardize some of the cloud APIs as they do for banking and as they do for fintech and so on. Yeah.
So something to keep an eye on. So usually you find a basic adoption of those standards and massive extensions that are incompatible to the standard. So you nevertheless are buying into a particular vendor. It's a classical pattern you'll find, I guess. Cool, right. So yeah, to wrap up the end, the motivation here. So cloud computing. If we want to get closer to the idea of why is it so affordable, why is it cheap to actually do that, we need to look at the economics that underlie it. It's basically the idea of economics of scale. So if you are minimizing...
So what does it mean, an economy of scale?
Okay, what's an economy of scale? Anyone?
Are you thinking that the more you have of something, the cheaper it is to have one of that thing? Like it becomes more efficient to have something if you have more of it?
Yeah, okay, resources, yeah.
Economies of scale is really about, it's a kind of a misleading term because it's really about automation and having like procedures which are standard, like simple procedures, like being able to do something a lot of times and then being able to like produce large amounts of stuff in very efficiently. And therefore, each item costs very little to produce. Right.
Yeah. That's right. That's part of it. Right. Concentration of service provision in a single hand, so it's optimized, or in few hands, in fact, and so it's very optimized, and the cost per output is way lower. Yes. So automation would be one way, and AWS does precisely that. Right. So they automate their own infrastructure using their own infrastructure. Not quite, but quite a bit. So yeah, so it becomes cheaper. So instead of you repeatedly setting up your initial first server with, I don't know, 16 gigabyte of 16 gigabyte of RAM and some terabyte of storage, well, if you do it on a larger scale outright and do it on one single server that has multiple of this capacity, it's a lot cheaper to rent it out to multiple individuals. The overall cost is way lower. So it will actually pay off to concentrate the computing power in one of few hands. Yep.
And there's one more aspect to it. That is like the administration cost is usually very low because you don't need to expand the administration at the same rate as you need to expand the capacity.
That's right. Yeah. So that's right. So you only need to have one set of, one larger administrative team taking care of it, as opposed to 16 for the individual companies, right? It also reduces need for training. You only need to know AWS, right? So you can get certified in AWS, as opposed to learning about server administration in great detail and perhaps even hardware, implications. I suspect that the next generation network administrators probably never actually need to deal with network cables anymore. So other than the one that's coming out of the wall for the actual internet connectivity on a local level, but it's pretty much all done virtually. The concepts are the same. It's just the realization is different, right? So, and even Cisco moves to that approach. If you're taking a Cisco course, some of you probably did with varying level of experience. So you probably virtualize a lot of those elements. They have this, was it packet, a simulator packet tracer, I think, which you can use to emulate big networks and their data flow as well. So, but that's the key idea. So you reduce marginal costs, so the cost for each individual additional service by having a larger service provision outright, so just such as AWS has, or all the other cloud service providers. That's the key idea. So a key motivation. Secondly, they can do it multiple times, do it anywhere. You have no chance of competing remotely with this. If you're one of those 16 companies, it would be pretty expensive to move closer to your customer, because you would need to replicate your own data center as opposed to just reusing any of the existing data centers provided by them. So that's the massive opportunities there. For you from a job perspective, there's also quite a bit of opportunities there. I think a few weeks ago I showed this slide here. It's basically the projection of revenue in cloud-related technologies in the next coming years until 2020. Perhaps the only interesting pattern there is that it seems that SaaS and IaaS services have a much higher potential than conventional PaaS services. So specializing in Heroku may not necessarily be the perfect investment in your future, but actually looking at the available services by the bigger players may be something that's more worthwhile. No. And the SaaS adoption is probably not surprising. We will all move towards, Google-style services, right? This is not necessarily of relevance to technologists as such. It's just a pattern that our all the services on software services that we provide are simply adopted. The more important bit is the IaaS one. That is actually the fact that most companies will more or less switch to a IaaS infrastructure as opposed to hosting on PaaS services, right? Any surprises there?
No, yeah, we discussed it a little bit because the PaaS is probably like the entry to the ecosystem. So if you're a startup and you're doing something, or if you're prototyping something, you probably would use PaaS because that's the easiest CapEx versus OpEx kind of sweet spot. But as your product becomes more successful and as your costs grow on the PaaS, you switch to IaaS to minimize the operational costs that you would have on PaaS.
Yeah. Cool. So to complement this, and then afterward you get a break, reasonable timing in fact. Challenges, again, the obvious thing, dependent on others, the others will grow. So we'll have more AWS, Google, and Microsoft are going to become bigger players. Perhaps there's one or two others joining them because it's kind of contentious amongst the runner-ups in the cloud computing space, not for AWS, but the rest. And obviously it's also a kind of a pattern you see there. So it's a good opportunity. If you had, for example, done computing, let's say 30 years ago, you probably would have seen the very same pattern, usually in local networks, but you would have one big computer, one mainframe, and a lot of stupid thin clients, or terminals rather, as they were called, that would connect to it and basically operate on that central service. And we're moving back, we're reinventing that kind of cycle again, obviously with more computing power on the client side, relatively speaking, but absolutely speaking, even lower computing power probably, that we actually depend on a very centralized system. So it has advantages, but also disadvantages, right? Think about, major internet outage over multiple days. I think that was the IT for your business then. That you will not be able to do anything else, especially if you go beyond, for example, national boundaries or continental boundaries even. You suddenly depend on the centralization too much. Security, we talked about this. There's issues regarding policy, again, data storage, for example, or privacy, but also service level agreements. So you actually need to put more emphasis on legal aspects. So AWS needs to guarantee you, or if you want them to guarantee you certain uptime, they do this in service level agreements, and the more you want, the more you pay for it, right? So you can have a legal guarantee for uptime, which is now a big concern. So actually you need to bring lawyers or legal specialists at least into the game. when making strategic IT decisions. So it's a kind of a bit of a change from a conventional technologist perspective that we are kind of used to. And you guys need to eventually think about this as well. If you start your startup anyway, but even if you're a CIO or the like, or CTO, you probably need to deal with those issues on a regular basis. So I'll give you a break of 10 minutes. So 18 minutes past 1, we'll reconvene, and then we'll wrap up whatever is left here. And I'll try out, see if we can do a little quiz on what you know and what you still probably need to look up after that. Cool. Cheers.
Nu var det skulle ha